A rocket's riddle up, up, and away. But how? Have you ever gazed up at a star-studded night sky and wondered how we ever send rockets soaring into that vast expanse? It's a question that has captivated humanity for centuries. The answer lies in the fascinating science of rocket propulsion, a delicate dance of forces that allows us to overcome gravity's pull and venture beyond our planet. The sheer power of a rocket launch is awe-inspiring. It makes you think about the incredible forces at play, propelling a massive machine against the relentless tug of Earth's gravity. But have you ever stopped to consider how this incredible feat is accomplished, both here on Earth and in the airless vacuum of space? Earthbound firepower rockets and their terrestrial thrust. To understand how rockets work in the vacuum of space, we must first grasp their operation on Earth. The journey of a rocket begins long before it pierces the sky. Engineers and scientists meticulously design and test every component to ensure it can withstand the immense forces it will encounter. At their core, rockets operate on a principle you likely encountered in school, Newton's third law of motion. This principle is fundamental to understanding how rockets generate thrust. This fundamental law states for every action, there is an equal and opposite reaction. It's a simple yet powerful concept that governs the motion of rockets. In the context of rocketry, this means that when a rocket expels hot gas out of its engine nozzle, the action, the gas in turn exerts an equal and opposite force, propelling the rocket upwards, the reaction. This is the essence of how rockets achieve liftoff. This expulsion of gas is generated by burning propellant, a mixture of fuel and an oxidizer, in the rocket's combustion chamber. The choice of propellant is crucial, as it determines the efficiency and power of the rocket. The process creates a controlled explosion, generating thrust that lifts the rocket off the ground and through the atmosphere. This controlled explosion is a marvel of engineering, balancing immense power with precision to ensure a successful launch. The vacuum of space, an empty stage for a spectacular show. Now let's journey beyond Earth's atmosphere and into the vacuum of space. What exactly is a vacuum? In simple terms, it's a region devoid of matter, including air. Space, while not a perfect vacuum, is extraordinarily empty compared to the environment we experience here on Earth. This difference is crucial in understanding how rockets operate in space. On Earth, rockets rely on the presence of air to function. The air provides resistance against which the expelled gas can push, generating thrust. However, in the vacuum of space, there's essentially nothing for the expelled gas to push against. This might seem like a problem, but it actually works to a rocket's advantage. Section 4. Dancing with nothingness. Propulsion in a vacuum. Remember Newton's third law? For every action, there's an equal and opposite reaction. This fundamental principle is the cornerstone of how rockets operate, even in the vast emptiness of space. It still holds true in space, even without air. In the vacuum of space, the lack of air resistance means that the forces at play are different from those on Earth. In a vacuum, the absence of air resistance means there's nothing to slow the rocket down. This allows rockets to maintain their speed and trajectory more efficiently. The momentum of the expelled gas alone is sufficient to propel the rocket forward. This expelled gas creates a thrust that pushes the rocket in the opposite direction. This is why rockets are actually more efficient in space than in the atmosphere. Without the drag of air, they can use their fuel more effectively. They don't have to work as hard to overcome air resistance, allowing them to achieve incredible speeds. This efficiency is crucial for long-distance space travel. Think of it like this. Imagine trying to walk through a swimming pool versus gliding through the air on an ice rink. The difference in resistance is significant. The resistance of the water makes walking through a pool strenuous, while the near-frictionless surface of the ice allows you to glide effortlessly. This analogy helps us understand the challenges and advantages of movement in different environments. Similarly, the vacuum of space provides an almost frictionless environment for rockets to navigate. This allows for smoother and more efficient travel through the cosmos, making space exploration possible. Section 5. Space Travel Secrets, Unveiling the Cosmos, one launch at a time. The science of rocket propulsion in space is a testament to human ingenuity. We've harnessed the fundamental laws of physics to propel ourselves beyond our planet and explore the cosmos. But the marvels of space travel don't stop there. Did you know that spacecraft can use the gravitational pull of planets to slingshot themselves further into space, conserving fuel and enabling them to reach distant destinations? This technique, known as a gravity assist, highlights the elegance and efficiency of space travel. By understanding the intricacies of orbital mechanics and the interplay of gravity, we can navigate the vast distances of space with remarkable precision. Section 6. Vacuum Ventures, the importance of understanding space propulsion. Understanding how rocket launches function in a vacuum is not just an academic exercise, it's crucial for advancing space exploration and technology. As we venture further into the cosmos, we need to develop more efficient and powerful propulsion systems to overcome the challenges of long-duration spaceflight and interstellar travel. Whether it's sending humans to Mars, exploring the outer solar system, or unlocking the secrets of the universe, our ability to navigate space hinges on our grasp of rocket propulsion. By unraveling the complexities of this science, we open doors to new discoveries and push the boundaries of human understanding and innovation. Section 7. Beyond the Horizon, Our Future Among the Stars. The next time you witness a rocket launch, take a moment to appreciate the intricate dance of forces at play. It's not just a spectacle, it's a symphony of science and engineering, a culmination of years of research, testing, and human perseverance. From the roar of the engines to the fiery trail of exhaust, every element of a rocket launch is a testament to human ingenuity and our unquenchable thirst for exploration. The power and precision required to break free from Earth's gravity are nothing short of extraordinary. As we continue to unravel the mysteries of the universe, our understanding of rocket propulsion will undoubtedly shape our future among the stars. Each discovery brings us one step closer to making interstellar travel a reality. The future of space exploration is brimming with potential, and understanding how rockets function in the vacuum of space is paramount to realizing that potential. The challenges of deep space travel require innovative solutions and groundbreaking technologies. As we continue to push the boundaries of human exploration, the science of rocket propulsion will undoubtedly serve as our compass, guiding us towards new frontiers and unlocking the secrets of the cosmos. The journey ahead is filled with unknowns, but with each mission, we get closer to understanding our place in the universe.